Bismillahirrahmanirrahim. Welcome to my channel Learn Math with Sayyid Ali. Today our topic is basic trigonometric identities, and we have started this basic trigonometric identities from grade 10, but it also goes into the grade 11, and in some schools or in some boards it starts from grade 11 as well, right? So it doesn't start it from grade 10, but anyway we have to look into it, that what are basic trigonometric identities. So the first identity is called quotient identity. Sometimes it also comes into fill in the blank, right? So quotient identity. What is quotient identity? Quotient identity is sine theta over cos theta is equals to tangent theta, and we also prove it in one of our lecture that how sine theta over cos theta is equals to tangent theta. If you want to review how we proved that, by Sokatova. So when we put the sine theta value as so, and so was Sokatova, TOA. So sine was opposite over hypotenuse, right? Opposite over hypotenuse, and divided by cos, which is adjacent over hypotenuse. So when we did adjacent over hypotenuse, so what we are putting is sine theta divided by cos theta. So what I am saying is opposite over hypotenuse, adjacent over hypotenuse. So if this is this ratio, quotient, then what happened? O over H times H over A. It reverse, right? Flip it for multiplication. If something is in division, we have to flip it, and then it will be multiplication sign. H over A. So this cancels. Now we have O over A, and O over A is tangent theta. So that means quotient identity is sine theta divided by cos theta is equals to tangent theta. So any power of sine will remains like the same in this formula. Like if we have sine 9 theta divided by cos to the power 9 theta will remain 10 to the power 9 theta. So this is also one of the extension of this identity. Hope you understand this, right? So any power will also be remains like sine theta over cos theta is equals to tangent theta. So second identity is called Pythagorean identity. Pythagorean identity. This is also asked in fill in the blanks or question like mental math. Sine square plus cos square theta is equals to 1. This is called Pythagorean identity. And in this identity, we have several formation. We can make several formation. So this is sine square theta plus cos square theta is equals to 1. You cannot say that sine theta plus cos theta is equals to 1. No. So this is not. So only sine square theta plus cos square theta is equals to 1. So this is just for reminder that it is not equals to. So now we can have many formation like cos square theta. If I shift my sine square theta to the other side, I have 1 minus sine square theta. Or if I shift the other cos square theta to that side, I can also write this identity like this. These things you know very well, so this is no botheration. Wherever you have to flip it, you can flip it, right? You can say that sine square theta minus 1. If we bring this minus 1 there, sine square theta minus 1 is equals to minus cos square theta. Or you can flip cos square theta minus 1 is equals to minus sine square theta. So whatever identity remains same, right? You can flip the equation by your algebraic rule, right? The third identity is called reciprocal trigonometric ratio. Reciprocal trigonometric ratio. And this, up till now or until now, we have just dealing with sine, cos and tangent. But there are three more identities which are called reciprocal trigonometric ratio. So we have a reciprocal of sine, which is called cosecant, right? And the short form we say cosec. So wherever you see cosec theta, you have to understand it that it is reciprocal of sine theta. Reciprocal, right? Reverse. Reciprocal. So if sine theta is opposite over hypotenuse, cosecant will be reverse of it, right? H upon O, hypotenuse over opposite. Similarly, cos theta reciprocal is called secant theta. So whole word is secant, but for the short we write only sec theta. Sec theta or cosec theta. So these are the reciprocal of sine and cos, and the tangent theta reciprocal is called cotangent theta. So first I am writing the whole word cotangent theta, and then we say in short cot theta. And cot theta is reciprocal of tangent theta. So whatever you learn here, it will be just opposite of it, right? So we have sine, cosine and tangent, and then is reciprocal will be cosecant, secant and cotangent, right? So reciprocal is also written as like a sine inverse. So reciprocal means sine inverse, right? If you take the sine inverse, that means it is cosecant, right? Or when you say cos inverse, that means it is secant. So it can also be represented as sine inverse, cos inverse and tangent inverse. So what I am talking about is inverse. Inverse means reciprocal, right? Minus power means it goes into the denominator like this, 1 over sine theta, right? 1 over sine theta. This will be 1 over cos theta. This will be 1 over tangent theta. And 1 over tangent theta means if sine theta you know that it is opposite over hypotenuse over h. So 1 over h will be equals to h over O. Right? So this is how we write down the reciprocals. Or if you want to write this one as well, a over h. But the reciprocal is in the denominator, so it will be a over h. So O over h, h over O, and this will be h over a. Right? And this will be 1 over O over a, and reciprocal will be adjacent over opposite. So this is how we have this reciprocal trigonometric ratio. So you have to remember now the cosecant theta, secant theta and cotangent theta. Reciprocal identities. These are called reciprocal identities. So I can write here sine theta is equals to 1 over cosec theta, right? I will be using this several times when I will be solving questions. Cos theta is equals to 1 over secant theta. I will be using this identity, right? And then tangent theta is equals to 1 over cot theta, right? So these are the reciprocal identities. So you have to go through all these three identities and their several formation: quotient identity, Pythagorean identity, reciprocal trigonometric ratios. And we will be solving some questions so that you know how we deal with these identities in questions, right? So I am not cleaning out everything, but I am making some space so that you can see. So trigonometric ratio I can write again that sine theta is equals to reciprocal, right? So cosec theta and cos theta is equals to 1 over secant theta, and tangent theta is equals to 1 over cot theta. Or reciprocal is also true like this: cosec theta is equals to 1 over sine theta. If you take the reciprocal, it goes cosec, right? So this is how it is. Now we will solve some problems, some questions, like simple one first. So then we will enter into the difficult one in the next video, part 2. This is part 1 on basic trigonometric identities. Tangent theta, cos theta is equals to sine theta. So now question says prove the following identities. What question says? Prove the following identities. I will rewrite it. So with the maybe with the red, so that you have the question section now. So prove the following identities. So what is question number 1? We have here tangent theta, cos theta is equals to sine theta. Here we make use of the left side and the right hand side, and then we try to take one side and then try to make that equals to the other side. So here this is my left side LS and this is my RS. Now I am taking, because RS is simplified form, so I will take LS to work on. So tangent theta, I know from the identity that sine theta over cos theta. This is my quotient identity. So I replace tangent theta as this times cos theta, right? So what happened is here, cos theta cancels with cos theta. What I am remaining with is sine theta is equals to, sine theta was my RS, right? So now I have LS is equals to RS. Now I have LS is equals to RS. So proved. So this is how we make use of these trigonometric identities. This was a simple question, but we make use of that. Tangent theta, we learned that tangent theta is equals to sine theta over cos theta. So we make use of that identity and we got the answer. And the answer is that left hand side is equals to right hand side, right? Now we have another question for question number 2. Tangent theta plus 1 over tangent theta is equals to 1 over sine theta dot cos theta. So here again we have left hand side and right hand side. So LS, left side, I'll take left side because I can put tangent theta as sine theta over cos theta. So I'm putting it sine theta over cos theta. And 1 over tangent theta means reciprocal of tangent. That means I can write cos theta divided by sine theta. Hope you understand this, right? Tangent theta is sine theta over cos theta and 1 over tangent theta is reciprocal. Reciprocal means flip this. So I flip this cos theta over sine theta. Now I will take the LCM to simplify this, and my LCM will be sine theta cos theta, right? So cos theta cancel, and in the numerator I got sine square theta plus sine theta cancels, and I got cos square theta. So I use now another trigonometric identity, Pythagorean identity. Sine square theta plus cos square theta is equals to 1. So I have 1 over sine theta cos theta, right? Which is my LS or RS, right? So RS is equals to left side. Left side is equals to right side. And when left side is equal to right side, then we say that we have proved the identity. Proved, right? So this is how we make use of these trigonometric ratios or identities. We can take another example. So let me put another example here. So example is question 3. Let's say tangent theta plus cot theta, tangent theta plus cot theta is equals to what you can say secant theta and cosecant theta, right? Here again you have left hand and right hand side. So we will take this left side. Tangent theta I can write sine theta over cos theta, right? So I will be writing here sine theta over cos theta, and cot is reverse of tangent, so I can write here cos theta over sine theta, right? Now I have to take the LCM, which is cos theta and sin theta. When we divide cos theta, cos theta cancel. In the numerator, I got sin squared theta. Sin cancel. In the numerator, I got cos squared theta. So in the top, in the numerator, I got 1. So I have 1 over sin theta and cos theta. In multiplication, you can write either way, right? So no worries. So, but we can say that, we can separate them. I can say 1 over cos theta or sin theta first, whatever. 1 over cos theta, right? And we learn. What we learn? 1 over sin theta is cosec theta. So I can write here cosec theta. And 1 over cos theta is secant theta. So dot, right? Secant theta. And we can see that this is my right hand side. Right side, right side, right side. And we take the left side and make it equals to right side. That means LS is equals to RS. That is what we need to prove by the trigonometric identities. So we prove this identity too. We will go into the second part of this video, and then we will see the bigger expressions and we solve these trigonometric identities by the rules: quotient identity, Pythagorean identity, and reciprocal trigonometric ratios. Hope you like the video. If you like it, subscribe my channel, press the bell icon button, thumbs up. Thank you for watching.